All right, so we're on day 5. We're looking at function notation. Something that you'll know from today's vocabulary is the words domain and range. So the domain is a set of all the x values, which is also known as the input. And range is a set of all the y values, also known as the output. So we're going to look at some input outputs now. Just to familiarize with some of this. So if we're knowing that, if you're looking at this first example, it says if y is equal to 2x plus 3, find y when x is equal to 4. So they're giving us the input, right? So the input here is 4. So basically what we're doing, we're going to input the value of 4 and replace it every time we see the variable x. And what we're looking to get out of this, it was looking to find the output, which in this case is y. Okay, so if I was going to rewrite this now, I would have y equals 2. Now instead of x, I'm going to write 4 plus 3, right? Because that's our input. And I have y equals 2 times 4 is 8 plus 3, and y is equal to 11. All right, and then I'm going to do the same thing here for number 2, where they're saying that if g is equal to 4b minus 7, find g when b is equal to 2. So here again, the input in this case is b, and they're asking us to find g, which is the output. So to rewrite this, I would have g is equal to 4. Instead of b, I'm going to have 2 minus 7. G is equal to 4 times 2 is 8 minus 7. And g is equal to 1. And we'll do this again here. If p is equal to 4s, find p when s is 5. So I rewrite this. P is equal to 4 times 5. And here we'd have P is equal to 20. And here it says if y is equal to if y is equal to x raised to the second power, 5, find y when x is 6. So we write this as y is equal to, instead of x, I'm going to have 6. Raise it to the second power. Remember, when you're raising the second power, you're really just saying 6 times 6. That's what that means here. So y is equal to 36. Okay. So now that we got to look at some input outputs with domain and range, you want to use this new vocabulary word that we have. It's called function notation. So function notation is actually just that right there, which is f of x. Is a different way of saying y. So it's the new setup for writing equations that shows that how the output y depends on what is plugged in, or another word for plugged in would be substituted in, for the input y. F of x represents the output y, and it's read as f of x. Okay? So if we look back from that first example we had above, The value that we found for y depends on what we plugged in for x. Function notation allows us to see the input of x right in the equation. So, for example, as we had before, find f of x. If f of x is equal to 2x plus 3, find f of 4. Okay, so x, if you notice, is in the is the input, and is always in the parentheses. So there's some nice way to remember. It's always on the inside of the parentheses, and it's always our input. So we would rewrite this as f of 4 is equal to 2. Now instead of x, we would have 4 here plus 3. And then we know that f of 4 is equal to 8 plus 3, and f of 4 is equal to 11. All right, so we're going to try this together. Okay, let's try these two examples. So functions are basically just a game of inputs and outputs. And when we give you an input x, you should be able to find the output y, or we're going to use f of x, a new function notation. Just the same way, if we were to give you the output y or f of x, you should be able to find the input. So we're going to try to do those two things below. So the first example says if f of x is equal to 5x minus 7, find f of 2. Now remember, 2 is our input. Okay? So f of 2 is equal to 5 times 2 minus 7. So f of 2 is equal to 10 minus 7. And I wrote the answer. F of 2 is equal to 3. Now, if you notice to the problem on the right side, it says given f of x is equal to f of 5x minus 7, find x when f of x is equal to 3. So in this particular case, they're actually giving us the output. So that means you want to set this problem up as 3 is equal to 5x minus 7. So in this case, we're looking to find what x is. That's our goal. What is x? To do so, you want to use inverse operation, something we haven't gotten into yet, but we will so in our next unit, which is coming up. So if I want to move the negative 7 to the other side, I have to add it to both sides. Right, so I'm doing the opposite operation, which is inverse operation. I end up getting 0 here, and that would give me 10 is equal to 5x. Now I want to get x alone. So we know that 5 and x are being multiplied, so I want to do the opposite. So I actually wanted to divide by 5 because I want to get x by itself. And I would end up with 2 is equal to x. And here, that would be my final answer.